Good day, everyone. I'm Jenel Mendaros, and today I will be discussing all about the chemistry of environmentally friendly alkene oxidation methods. So, this topic focuses on how chemists develop safer and eco-friendly ways to perform chemical reactions, especially in converting alkenes into useful products. So, the effort to develop a synthetic methods that are environmentally friendly is very active area of chemistry research. The push to devise green chemistry procedures includes not only replacing the use of potentially hazardous or toxic reagent with ones that are more friendly to the environment, but also developing a catalytic procedures that use smaller quantities of potentially harmful reagent when other alternatives are not available. So, what exactly is green chemistry? So, as an introduction, green chemistry is the design of chemical processes that reduce or eliminate the use of harmful substances. So, in green chemistry, instead of using toxic chemicals, scientists aim to use a safer materials that are less damaging to humans and especially in the environment. So, what is the purpose of green chemistry? Or so, what is the goal of chemistry, green chemistry? So, the only goal is to protect the environment. So, how? So, this includes reducing pollution, minimizing hazardous waste, and using a fewer harmful chemicals. And also, it focuses on using a catalyst so that only small amounts of chemicals are needed. And we also have traditional methods and green methods. So green methods is the way of developing or the way of process of the how in making a green chemistry. So the difference between the traditional and the green method is in traditional, I'm sorry. So in traditional met the methods they use a strong and toxic oxidizing agents like heavy metals. So, and this can be dangerous and harmful to the environment. So, in contrast, green chemistry replaces this with a safer alternatives and making a reactions cleaner and more sustainable. Yes, from the word itself, green. So, the catalytic scene 1 to the hydroxylation methods, including the sharpless asymmetric dehydroxylation procedure, require only a small amount of osmium tetroxide or other heavy metal oxidants. So, as you can see here is the summary to more understand it. So, these methods are very environmentally friendly because this they they reduce the amount of toxic heavy metals used that is used, such as the osmium tetroxide or OSO4, by using a small catalytic amounts. So they use only a small catalytic amounts to reduce the harmful toxic or amount of toxic heavy metals. So, nature has provided hints for ways to carry out the environmentally sound oxidation as well. So, the enzyme methane monooxygenase or MMO uses iron to catalyze hydrogen peroxide oxidation of small hydrocarbons, yielding alcohols or oxide. So, scientists also get the ideas from nature itself. For example, the methane monooxygenase uses a iron to catalyze oxidation reactions safely and it will produce a alcohols or producing alcohols or epoxide. So, 1 to 2, as you can see here, there is a procedure that developed by LQ and E. Jacobson. So, in LQ, it yields a mixture of 1 to 2 diols and epoxide by action of an iron catalyst and hydrogen peroxide on an alkene. So the ratio of diol to epoxide formed depends on the reaction conditions, and in the case of the hydroxylation, which is the procedure, shows some enantiomer selectivity. So another green reaction is the ep- epoxidation method developed by Jacobson of the Harvard University, which is Jacobson procedure uses hydrogen peroxide and a similar iron catalyst to epoxide alkenes without the complication of diol formation. So in conclusion, um, we can see that use method procedures produces a mixture of diols and oxide. So diols and epoxide using an iron catalyst and hydrogen peroxide. While Jacobson's method, on the other hand, produces only epoxides efficiently. So, much more or mas marami si Hughes than si Jacobson. And in addition to that, Hughes and Jacobson's method are considered eco-friendly because they use a non-toxic metals like iron, which produce less waste and use a safer chemicals. Also, hydrogen peroxide is converted into water, so making it environmentally safe. So in addition, catalytic methods reduces the amount of toxic oxidants like osmium tetroxide. So this slide shows the structural changes in both Jacobson's and Q's iron catalyzed oxidation reactions of alkenes. So here in Q's iron catalyst reaction, an alkene with a fixed group reacts with the hydrogen peroxide. So the main product form is syn 1,2-diol with 81% yield and 60% enantiomeric exist, while a smaller amount of epoxide, about 13%, is also formed. So this happened because the iron the iron catalyst activates hydrogen peroxide and it leading to two possible reaction pathways, which is the dehydroxylation and epoxidation. It resulting in a mixture of product, which is this two. So in contrast, Jacobson's iron catalyst method also uses hydrogen peroxide, but it produces almost exclusively an epoxide with a high yield of 85%. So no significant diol formation occurs because the reaction conditions such as low temperature and acetic acid and controlled peroxide amount and direct the reaction towards only a single product. So, but both of these methods are considered green method because they use a non-toxic iron catalyst and hydrogen peroxide, which produces water as the only byproduct. So, however, Jacobson's method is more selective since it produces only epoxide compared to Q's method, which gives a two mixture or which gives a mixture. So also, this slide shows the structural difference between Jacobson's and Q's reactions. So in Jacobson's reactions, the alkene is directly converted into an epoxide ring through a syn addition of oxygen, and it's highly selective. So only the epoxide is formed under mild condition. While CQs and Qs or Qs reaction, the same alkenes react with the hydrogen peroxide and an iron catalyst. But the main product is a syn 1,2 diol with a small amount of epoxide also formed. So this happened because the reaction can also follow two pathways, or the reaction can follow two pathways, yes. So overall, both of these use a green oxidant, but Jacobson's method is more selective. Again, it's more selective, while his methods gives a mixture of two products. So in real life application, so in real life, these methods, as you can see, it used in industries for safer chemical production, reduces pollution and hazardous waste, protects workers from toxic chemicals, promotes environmentally friendly products, encourage awareness of safe chemical practices. So these are what are the real life application of green chemistry. So in real life, these methods are very useful, are used in industries to produce chemicals in a safer way. So they help reduce pollution and minimize hazardous waste, making the environment cleaner. And so at the same time, they protect workers from exposure to toxic chemicals. So these methods also promote the use of environmentally friendly products. As students, we can apply this by being more aware of safe chemical practices, and like in the lab when we're doing a lab, no, and supporting products that are better for the especially in the environment. So in conclusion, for our conclusion, the quest for more methods in green chemistry with benign reagents by byproducts and catalytic cycles and highly yields will no doubt drive further research by present and future chemists. So, in conclusion, environmentally friendly alkene oxidation method shows that chemistry can be both useful and safe. So, by using a green chemistry principles, we can protect the environment while still advancing science. So, I think that will be all for today. Thank you for listening and goodbye.